Hi, this is Mrs. Slater, and today we're going to talk about solids of rotation. And in this first one, I'm not going to do the whole example for you, but I at least want to show you a program called Mathematica that will help you see what this rectangle is doing. So the rectangle itself is bounded by these four sides. And when you rotate that around the y-axis, it's going to create a certain picture, which looks like this. So I'm going to rotate it around a little bit so you can see what happens. The axes would be right down the middle of this picture. So I'm just going to rotate it a little more so you can see. Everything would be filled in, by the way. This would just be the outline of the outside of the cylinder. So I think that gives you a good idea of what the solid or the three-dimensional figure will look like. All right, so let's go on to the next one. Number 2 has a region that is bounded by the x-axis, y-axis, and a line, and that's creating a triangle. So if you rotate it around the y-axis, it's going to look a lot like this. So I'm going to rotate this around just a little bit. So it's going to, any triangle is going to create a cone, and you can kind of get a visual of what's going on inside. Again, all of that would be filled in, but the three-dimensional figure of a triangle turns out to be a cone. So it's reflected around. So I think I've gotten all the angles of that one. So let's go on. The third one's region looks something like this. And if it is rotated about the x-axis, it's going to look something like this. Let me find it really quick for you. It's like a rectangle, looks like a cylinder, but then there's this empty space in the middle. Okay, so let's see if I can give you some more views here. And I see that all the space inside would be filled in. Oops, I guess it doesn't let me write anything on it. Okay, so then all that space would be filled in, so you're getting a cylinder within a cylinder. So hopefully that makes it make a little more sense on what that picture is doing. So, all right. Now let's go back to the fourth one. And in the fourth one, the region that it's bounded by, it gives you a picture of a circle. So the center point is at 0, 3. And then you have a radius of 4. So you're going to go out 4 in each direction. Okay, but it only wanted where x was equal to 0. So you only really need this half a circle right here. Okay, and if this picture is rotated about the y-axis, it's going to turn into a picture that looks like this, a sphere. So no matter how I turn it, you're just going to see a sphere all the way around, and all that is filled in inside of there. Okay, so now in the fifth one, I'm going to get a little more detail on how to find the surface area and the volume, because these are pictures we haven't seen in any of our assignments. Okay, so first of all, the picture. If we're going to go ahead and do the region, if you haven't had a chance to do that, go ahead and push pause and plot those on your graph. Okay, so that's what you should get a picture of. Never mind. Here's the real picture. It should be a triangle. So then this triangle, when it rotates around the x-axis, is going to look something like this. Let me go all the way up to the top. Now in Mathematica, there's going to be a little bit of overlapping, but you can see, like, if I can get this to be flat, like maybe look more like the picture. Hold on just a second. Okay, I think I have this lined up correctly, but you can see the top half of this picture is going to have the triangle. So if you cut it off where in between the 0 and the -5 on the side, at like, I guess that would be 2.5. At 2.5, all the way, a horizontal line, that's the top. And when it spins, it's creating two different cones. So if we can find the surface area and volume of one cone, then we can just double whatever we find. All right, so let's go to the math part. Let me get rid of this, and let's take a look at the other part, the other side of it. So you have another picture that's going to look like this. And so when it rotates, what I was trying to explain is that this right here, if you cut cut that in the middle, that would be the biggest circle in that spot. So it's creating cone number 1. And then on this side, you've got another cone to also find. Okay, so since we know it's a double cone, let's go ahead and find the lateral area. The lateral area is going to be pi times radius times the slant height. Pi and radius are easy enough to get, but the slant height we're going to have to work at a little bit. And we have 4 and a 6 in the picture. And then once you find the hypotenuse, then you get 2 radical 13. So I'm going to multiply that by 2 radical 13 for a final answer of 12 pi radical 13. Okay, now there are 2 cones. Therefore, the total surface area is going to be doubled. So 24 pi radical 13 would be the final answer for the surface area. Okay, now let's move on to volume. Volume of a cone is 1/3 pi r squared times height. And there are 2 of them. We'll go ahead and do that in a second. But 1/3 pi r, that's pretty much easy to get. But the height is going to be the 4, which is this right here. Look for the purple in the picture. And after you put all that together, we end up with 48 pi. And then we're going to have to multiply that by 2 just because there are 2 of the same exact cone for a final answer of 96 pi cubic units. Okay, so let's go ahead and go to number 6. Number 6 is sketching the region. Go ahead and push pause and get the picture sketched. So your region should look something like the green triangle. And when that is rotated around y equals 1, it's going to create a picture that looks something like this. So let me move it around a little bit so you can see it. So it ends up being a cone within a cylinder. And we've seen that before when we were practicing dancing with Pythagoras. Let me see if I can move it around a little more. And again, everything between the cone and the cylinder would be filled in, like all that area right there. But then on the top part, that cone is going to be empty. So it's like a waffle cone without the ice cream. Okay, so let's do the work now on how to find the surface area and the volume. You would have another 3 going this way, and then it would connect. It would look something like, oh. Okay, sorry about that. I just have to erase and start over again. We're rotating around y equals 1, so it's going to be the green and the red. And we know that it is a cylinder, so the surface area is going to be a mix of the lateral area of the cylinder, and it's only going to be plus 1 base because the top is open, and then plus the lateral area of a cone. Okay, so the lateral area of the cylinder is 2 pi r h. The area of the base is pi r squared, and the lateral area of a cone is pi r times the slant height. Okay, so we know that the radius is going to be 3 because of this length right here. We know the height is going to be 9 because of this length. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, the radius again is going to be 3. And then pi times radius. And then we have to do a little bit of work for 3 radical 10, but after the Pythagorean theorem, you've got 9 squared plus 3 squared, and that's 81 plus 9, and then the square root of that ends up being 3 radical 10. So then 3 radical 10 is the slant height. And after combining everything together, we get 54 pi plus 9 pi plus 9 pi radical 10 for a final answer for the surface area of 63 pi plus 9 pi radical 10. All right, now on to volume. Volume, if we take the volume of the cylinder and subtract the volume of the cone, we'll be able to get the answer. So on this one, it would be pi r squared if we use our formulas, and then 1/3 pi r squared times h. Fill all of those in, and it would be a 3. squared times 9 minus 1/3 pi 3 squared times 9. If you put all that together, you get 54 pi. Okay, on to the next one. Okay, number 7. Already I have to tell you that the answer in the bottom of the page is wrong for 7A and B. And let's go ahead and begin looking at the picture. So take a second and get the region first. So for number 7, you have a region bounded by the triangle. If you go to Mathematica, you can see what it looks like. And the top triangle where it has 0, that's going to be the triangle you just formed. And when you rotate it, what ends up happening is you're going to get an opening through the middle. So the cylinder ends up getting created, and it looks something like that. It's a frustrum with a cylinder inside. So let me keep giving you some different views here. So it's going to be open in the middle, and everywhere between the cylinder and the frustrum is going to be solid. Okay, so we have to find the surface area and the volume of this figure. So for the sake of time, I went ahead and wrote down the surface area because we have to do the cylinder, the frustrum, and the base, which would be the circle minus the circle, like a little donut. And I had the numbers all filled in because I think I'm going to run out of time. So check over on my work, make sure that it all makes sense to you, and you can ask me questions tomorrow. Okay, and then the last one is the same picture, but now we're going to rotate it around x equaling 4. So it's going to create a cone. And it's similar to the picture that we've done before with the cone, so let's get right to what we need to talk about, which is the formulas. Okay, so you have a cone that looks like this. Height is going to be 3, and then the radius is going to be 6. So the surface area is pi RL plus 1 base, and then pi times 6 times 3 radical 5, and that's from the Pythagorean theorem, and 6 squared. Put all that together, 18 pi radical 5 plus 36 pi. And the volume is 1/3 pi r squared times height, 1/3 pi 6 squared times 3, and if you multiply all that together, you get 36 pi. All right, so again, check my work, make sure that you don't have any questions, and if you do, I can answer those tomorrow for you. And I hope you enjoyed the video today. Ta-ta for now.